Yes, it's a bold statement to make, but allow me to explain myself. A couple of weeks ago I got myself challenged by a flat earther after I criticized a video and suggested a falsification test. Now, I'm working on his challenge, but I also have a life, so it's going to take some time. But as I was working on that challenge, and I will put the video up later, I realized that the flat earth evidence doesn't prove a thing. Let's take a look at the scientific method. Now, there's this phenomenon like seeing the Isle of Man when you shouldn't. You hypothesize the Earth is flat. Then you would need to take systematic observations, do some data collection, data analysis. After this you would need to test your hypothesis. Now, let's take a look at the flat Earth evidence. Basically, it's all dependent on one observation made over and over again. Now, you could say that this is systematic observation and data collection, but I don't see a wide variation in circumstances, which would mean there's no system in the repeated observations. Additional, the problem with this is, for every observation made to indicate flat Earth, there's also an observation that indicates globe Earth. So what you would need is a test in which either you take out all the variables or you would test the same situation with all the variables. When you've thoroughly tested the situation, you need to find supporting evidence in different aspects of your model. So the whole testing sequence starts all over again. Now, the globe model has this. In the globe model, there are observations of objects over the horizon, measurable sun angles, measurable view angles on Polaris and the Southern Cross. There are accurate and corresponding travel times and travel distances, but also plate tectonics, earthquakes, volcano eruptions, climate, seasons, and the weather patterns that support the globe model. And I'm sure I left out plenty of other things. So, not only would flat earthers need to do the same tests in different circumstances, in different weather, with humid air, dry air, with and without refraction, from different elevations, from different locations, at different times, etc., and do this in all different combinations. You would also need to do the same tests from the Isle of Man towards Great Britain. In the same way you did the other tests in order to falsify the hypothesis, and then you would need to compare the results. Do the same mountains rise over the horizon at different heights, at different moments, or in different circumstances? If that's so, that would tell you something. So, if you can't falsify the hypothesis, then it is valid. But then, you need to hold it to your model and test all the other aspects of your model and do all the work again for these different aspects, like taking pictures of Polaris from different latitudes and see if the view angles correspond with your model. If you can falsify your hypothesis, then it isn't valid, and you will need to adjust your hypothesis. You can't just take a picture of the Isle of Man and say, I can see it when the globe model says I shouldn't be able to see it, therefore the Earth is flat. You need to be able to support your hypothesis. If you can't, then your hypothesis is wrong. Thanks for watching.